All right, good morning everyone. My name is James Dottin and I'm a postdoc at the Carnegie Earth and Planets Laboratory. Today I'm presenting a project where we looked at lunar glasses that were collected during the Apollo 17 mission. So during this mission, the astronauts went to a certain site and they took a trench of material that's, if you can see here, is quite a bit orange. And in this soil, there are orange glass beads. These are materials that formed when there was a fire fountain eruption and melt globules quenched very quickly in the lunar atmosphere. And what's unique about these glass beads is not only do they preserve the geochemical information associated with the eruptive melt, but they also have a layer of condensed vapor that's associated with the volcanic plume from that fire fountain eruption. And in my work, I use sulfur isotopes to study how volatiles were processed during the earliest stages of the moon's evolution, and specifically for this project, how we can use sulfur to understand what these orange glass beads can tell us about the geochemical nature of the lunar interior. So here I have plotted these isotopic, sulfur isotope notations, and what's most important in this plot is this cap delta 33s notation, which we use to identify mass-independent fractionations. And when we think about the earliest atmospheres of the Earth and Mars, we know that those atmospheres were optically thin and allowed for the penetration of ultraviolet light. And this penetration of ultraviolet light in interaction with gaseous sulfur molecules produces this variability in cap delta 33s. On the moon, until this study, we've had no evidence that there was any mass-independent fractionation. And so we look to these orange glass beads to see if the condensed vapor associated with the cloud that also interacted with UV has any evidence of this mass-independent fractionation. In our data for the orange glass beads, we do see variability in cap delta 33s, but given the way we have analyzed our samples, which is by sieving them and looking at a variety of sieve fractions of these orange glass beads, the data don't necessarily indicate that the process of UV interaction during the eruption of the glass beads is what caused this variability, but rather this is a signature that's associated with the source on the moon. And given that we do see, again, this anomalous signature, it's representative that the lunar mantle is likely heterogeneous in terms of its sulfur sources. And this is indicative that perhaps there was early recycling of sulfur on the moon, or that the lunar mantle has a primordial signature that is different from what we thought before, and it's something that is shifted in cap delta 33s, where there was mass-independent fractionation occurring in the early solar nebulae. Thank you for tuning in to my quick little summary, and I look forward to any questions you may have. So I'm excited to announce that I will be starting as an assistant professor at Brown University, July 1, 2023. And what's more exciting about this opportunity is that I'm looking for graduate students, I'm looking for postdocs and lab techs to help me build my lab. So if you are interested, please feel free to send me an email. It should be linked associated with this video. Thank you.